Hey everybody, this is Mr. Lowry. Today we're talking about factoring a sum or difference of cubes. Oops, I already caught a typo. That should say or difference of cubes. Alright, well let's talk about what that is. Sum means add, and difference means subtract, and a cube is just some number cubed, or some variable cubed. Okay? So for example, number 2 is a sum of cubes because that is x cubed, and this is actually 8 cubed. And now you may not know that just from looking at it. I'll show you how to take a cube root here in a minute. But that's what we have here on this assignment. So this is what we call a sum of cubes. Number 4 here, we have what we call a difference of cubes, because this is u cubed, and I believe this is 9 cubed. We'll go back and look at that in a second as well. So that's what we have here on this assignment, and there's actually just kind of like a formula or a template that we use to factor these. Now, if you want to know where that formula comes from, you should actually probably know where that comes from. It comes from what we talked about in class today. So today, in class, we did this in-class assignment where we multiplied a bunch of, basically we took a binomial and a trinomial and multiplied them together to see what the results were. And we did that a bunch of times, and we looked for some patterns, and we found some patterns, and now we use those patterns to help us factor. So the patterns that we kind of talked about in class today that we came up with is when we have something like, when we have a sum of cubes like this, we know where it comes from. It comes from a binomial that looks like a plus b times a trinomial that looks like a squared minus ab plus b squared. Okay, so that's just the template that we came up with today. We got it from just doing a lot of multiplication and figuring out that something like this will result in something like this. Okay, so that's what we want for this sum of a cube. Okay, now what we need to do here before we continue is we actually have to figure out what the a part and the b part are, because when you think about this template, you have something cubed, and then you take basically the cube root, right? Like we don't want a cubed, we want just a. So if we get from a cubed to a, we take the cube root. To get from b cubed to b, we take the cube root, and then the a and the b are what we use, and we just kind of fill out our template. All right, so when we see this sum of cubes, the first thing we're going to do is we're going to figure out what our a and our b are. And we do that just by taking the cube root of the two terms that we see here, and don't worry about any signs that you see. We'll talk about the signs in a minute. All right, so the cube root of x to the third is just x. The third power and the third root are inverses of each other, and they cancel out. Okay, now if you want to know how to do a cube root on your calculator, or if you're not sure if 512 is actually a cube root, here's how you do it. Okay, so there's a square root button here, but right above the square root, it's kind of hard to see in gold or yellow here, there's a cube root. So on this type of calculator, you go shift square root, okay, and that'll give you a cube root. You want to see a little 3 in here. And then we go 512, and turns out it's 8. Okay, other calculators have this button that has like an xth root. In this calculator, it looks kind of like this. So sometimes there's a button where you can like choose your own index number or your own root number. So I can be like, okay, I'm going to make that a 3, and I'm going to arrow over. So your calculators will be slightly different maybe, but basically we're looking for a third root. Okay, so x and 8 are the pieces that I'm going to use. So I already know what the template looks like. I mean, if you think about this right here, basically what it is I have an x to the third plus an 8 to the third. Right, that's what this is saying, because that's 512 is 8 to the third. And so basically I just take this whole template and I just replace all of the a's with x, and I replace all of the b's with 8s. So that's going to look something like this. X plus 8, and then I'm going to have x squared minus 8x, right? So a times b minus a times b, and then plus 8 squared, which is 64. And that is pretty much it. Okay, we just follow the template. We just replace all the a's with whatever a is, we replace all the b's with whatever b is. We just find out what those are by taking the cube root, and you're off. Okay, now that's how it works for the sum of cubes. So there's a sum and there's a sum. Difference of cubes is almost exactly the same, but the signs are a little bit different. So when we're factoring a difference of cubes, first of all, we have to start with a difference of cubes, right? Something cubed minus something cubed. And what that factors to is a linear binomial, usually a minus b. Okay, and then we're going to have a squared, this time a plus a times b, and then a plus b squared. Okay, so you kind of have to just memorize those. I mean, you can have them written down for your homework assignment, but on the upcoming test, you're going to have to know what those formulas are. So I would recommend practicing and writing them a few different times and trying to do them from memory so that you can practice. Okay, so we know what our format is. We just got to figure out what the building blocks are. So what are the a's and the b's? So we're going to take the cube root of u to the third. That's going to be u. We're going to take the cube root of 729. Pretty sure that's 9. Let's double check. Okay, so that's 9. So a is equal to u and b is equal to 9. All we're going to do is we're just going to fill out this template, and we're just going to replace all the a's with u's and all the b's with 9s. Because really what we have when you see the u cubed minus 729, what we have is u cubed minus 9 to the third. Because 729 is just 9 to the third. And so the pieces that we're using here are u and 9. So we have u minus 9, u squared, plus 9u, plus 81, which is 9 squared. That's it. You just take these two guys and you just replace in the template. Okay. Now, that may not seem like too much trouble, and it's really not as long as you know those formulas. But the real point, the real learning here was actually what we did in class, the in-class assignment where we actually figured out and derived where these formulas came from. So if you were in class, hopefully that made sense and you kind of understand where these come from. If you weren't in class, I would recommend going back and looking at that in-class assignment. I've posted it in Canvas, so you can go back and check it out. You can try it on your own, kind of work through it, and see if you can spot those patterns as well. We also, I put up a note sheet as well. It was just like a little mini note sheet that we did with those formulas and kind of just unpacking some of the ideas from that in-class assignment. All right, let's move on to the next guy here. Okay, now the next few here are a little bit different because there's a number in front of the variable, and that's okay. We're just going to take the cube root again. So now we just have two things to take the cube root of. The cube root of 64, we'll figure out what that is. Okay, so that's 4. But